NASA's Pilgrim 1 spacecraft, which currently holds the record for the farthest distance traveled by any human-made object, has captivated the world for nearly half a century. Since its launch, Voyager 1 has sent back crucial data from the farthest reaches of space, expanding our knowledge of the cosmos. However, the spacecraft's ongoing transmissions have recently encountered mysterious anomalies that have puzzled scientists. These strange signals have sparked intense debate, leaving the scientific community to wonder whether they are simply a malfunction or could indicate something far more extraordinary, perhaps even extraterrestrial phenomena. Join us as we explore these perplexing transmissions and consider what might be hidden in the vast expanse of space. Humanity's drive to explore the unknown has always propelled space exploration. This innate curiosity led to the creation of ambitious missions like Pioneer 1 and Explorer 2, which were some of the most daring space missions of their time. On August 21, 1977, the launch of Explorer 2 from NASA's Kennedy Space Center signaled the beginning of a transformative era in space exploration. Shortly after, on September 5, Explorer 1 followed, embarking on a path that would take it on a trajectory toward the outer planets, significantly affecting its orbit and mission outcomes. Throughout their journeys, these two spacecraft, each weighing about 720 kilograms, roughly the size of a small car, set off in different directions and at varying speeds. On December 15, 1977, a critical milestone was reached when Explorer 1 outpaced its twin owing to the different courses they followed. Since then, Explorer 1 has become an invaluable tool in expanding our understanding of the universe, offering insights that have changed how we perceive space. Before diving into Explorer 1's most recent groundbreaking discoveries, let's revisit some of its earlier significant achievements. In 1978, while it was about 265 million kilometers from Earth, Explorer 1 successfully captured detailed images of Jupiter. By January 1979, it completed a remarkable 100-hour mission, producing a time-lapse video of Jupiter's rotation. This series of 3,750 images provided unprecedented views of Jupiter's turbulent atmosphere and complex features. During this mission, the spacecraft discovered a previously unknown ring surrounding Jupiter and also identified two new moons, vastly enriching our understanding of the gas giant's intricate system. To ensure its safe journey and avoid any collisions with Titan, one of Saturn's moons, the spacecraft executed a series of correction maneuvers. After these, the mission's focus shifted beyond the planets of our solar system as the spacecraft was redirected toward interstellar space, traveling at a staggering rate of 325 million kilometers annually. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable feats, including the discovery of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and capturing some of the most iconic images of our solar system's outer realms. On February 14, 1990, at a distance of around 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning images of the inner planets. This collection of 60 photographs joined the spacecraft's portfolio, which included a total of 670 images taken during its flyby of Neptune. Meanwhile, Explorer 2 achieved its own remarkable milestones. During its mission, it recorded wind speeds exceeding 13,100 meters per second, the fastest recorded winds in the solar system, giving scientists essential insights into Neptune's distant atmosphere and its moon Triton, where surface temperatures reach a freezing 391 degrees Fahrenheit, making it one of the coldest spots in the solar system. Triton also exhibited ice volcanoes ejecting nitrogen gas and frozen particles up to 5 kilometers high, offering an exciting new perspective on the moon's features. These extraordinary findings deepened our understanding of the diverse and dynamic environments in the outer solar system. The contributions of both Explorer 1 and Explorer 2 have been nothing short of revolutionary. Their missions uncovered previously unknown details about the moons of Jupiter and Saturn, which had been considered dormant. These findings have reshaped our understanding of the geologically active nature of these moons. In particular, Explorer 2 made history by being the first spacecraft to fly by both Uranus and Neptune, an achievement that has yet to be replicated. NASA employed a variety of innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have dedicated themselves to this extraordinary journey. The design of Explorer 1 and Explorer 2 reflected cutting-edge engineering. These spacecraft were built to rotate slowly, minimizing blurring in the images they captured as they moved through space. Even before reaching the outer planets, the spacecraft began transmitting detailed images of Jupiter, revealing its swirling clouds, an iconic great red spot, a massive storm that has fascinated scientists for decades. However, the most thrilling discovery was the identification of active volcanoes on Jupiter's moon Io. The spacecraft's instruments picked up unusual signals from the moon, which were later confirmed by images showing towering volcanic plumes and a surface marked by intense eruptions. One of Io's volcanoes erupted with a force 1,000 times greater than Mount St. Helens, covering an area nearly as large as France. As the spacecraft continued on their journey, they were eventually powered down to conserve energy before embarking on their voyage into interstellar space. Remarkably, the images they captured did not include Mercury or Mars due to technical limitations. NASA later launched other notable spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the farthest spacecraft from Earth. Despite this, Explorer 1 continued its solitary journey for an additional 14 years, before entering interstellar space on August 25, 2012. The success of these Explorer missions was largely due to the innovative use of gravity assist maneuvers, which helped propel the spacecraft to their destinations while conserving fuel. As Explorer 1 approached Jupiter, the planet's immense gravity accelerated the spacecraft. Such precision was necessary to avoid disastrous deviations in trajectory or speed, allowing the spacecraft to successfully navigate their journeys through the solar system and beyond. Reflecting on the immense achievements of these missions, we eagerly await further insights into the recent anomalies detected by Explorer. The Voyager spacecraft continue their missions beyond the known limits of our solar system, exploring the mysteries of Jupiter, Saturn, Uranus, and Neptune. These missions have not only advanced scientific knowledge, but also sparked public interest in space exploration. The stunning images of distant planets, along with the personal stories behind the spacecraft's missions, have inspired millions worldwide. The breathtaking photographs of Saturn's rings and Jupiter's volcanic moons have become iconic, encouraging the next generation of scientists and explorers. As Explorer 1 and Explorer 2 continue their journeys into interstellar space, scientists remain eager to decode the mysterious anomalies recently detected in Explorer 1's transmissions. These unusual signals have sparked a wave of speculation, ranging from simple malfunctions to the tantalizing possibility of extraterrestrial communication. The enigma of Explorer 1's signals. The first sign of these anomalies appeared in late 2024 when Mission Control received unexpected fluctuations in Explorer 1's signal strength. Initially dismissed as minor interference caused by cosmic radiation, the irregularities soon became more pronounced. By early 2025, the anomalies evolved into structured repeating patterns, something that natural cosmic noise or onboard system failures typically do not produce. Scientists working on the mission were faced with an unsettling question. Could this be an artificial signal from beyond our solar system? To investigate, researchers analyzed the frequency modulation and duration of the signals. The data suggested that the transmissions followed an organized pattern unlike any previously recorded system malfunction. Some theorized that these signals could be echoes of Explorer 1's own transmissions, reflecting off an unknown interstellar structure or object. Others considered the possibility that the spacecraft had inadvertently detected a cosmic phenomenon yet to be understood. NASA, along with international space agencies, launched an extensive effort to decipher the message. The SETI Institute, Search for Extraterrestrial Intelligence, became involved deploying radio telescopes to cross-check the transmissions. Could this be the moment humanity had long awaited, a direct sign of intelligent life beyond Earth? unknown cosmic phenomenon. Some astrophysicists propose that the signals originate from a naturally occurring interstellar event, such as the interaction of powerful magnetic fields beyond the heliopause. It is possible that Explorer 1 is detecting something akin to fast radio bursts, FRBs, intense but short-lived bursts of energy from deep space. Interstellar reflection. Others suggest that Explorer 1's own radio waves might be bouncing off a dense plasma cloud or even an interstellar object, creating the illusion of an external transmission. This hypothesis remains under investigation as scientists examine the spacecraft's trajectory. Extraterrestrial origin. The most speculative and exciting theory is that the signals originate from an advanced civilization. If this were the case, the challenge would be deciphering whether it is merely a stray signal or a deliberate attempt at communication. Given the complexity of interstellar travel and the vast distances involved, many scientists remain cautious about jumping to conclusions. Regardless of the true source, these anomalies mark a pivotal moment in space exploration. If proven artificial in origin, the implications would be profound, potentially rewriting humanity's place in the cosmos. The future of deep space exploration. As we await further developments from Explorer 1, space agencies worldwide are accelerating their efforts to push even further into interstellar space. Several next-generation missions have been proposed. Interstellar Probe, ISP. A NASA mission designed to travel beyond the heliosphere at unprecedented speeds, reaching distances that even Voyager 1 and Explorer 1 have not yet achieved. Breakthrough Starshot. A privately funded initiative aiming to send tiny high-speed spacecraft toward Alpha Centauri, our nearest star system, within the next few decades. The Artemis program and Lunar Gateway. While focused on the Moon, this initiative lays the foundation for future crewed missions to Mars and beyond, paving the way for human exploration of the outer solar system. The discoveries made by Explorer 1 and Explorer 2 have already transformed our understanding of space. Now, as their journeys continue beyond the known limits of our solar system, they remain our most distant ambassadors, silent travelers carrying humanity's hopes, questions, and dreams into the unknown.